Hi, it's Adeline, and I'm going to present my PowerPoint that I made. So my project was ping pong. So here's a summary of ping pong. What is the object of the game? The object of the game is to hit a ping pong ball, so it's really lightweight, on the table and get points. So there's a ping pong table with a net in between. You have to try to hit it to the other side of the net. So how do you play? There's a table with a net in the middle, as I said. You have to try to hit the ping pong ball to the other side of the table. When the other person hits the ball onto your side, you have to let the ball bounce once on your side and then hit the ball over the net to the other side. Make sure that the ball doesn't go off the table, because if it goes off the table, then it's the other person's point. Same for them. If their ball goes off the table, then it's your point. Where is it played? It's played on a tabletop with a net, like shown in this picture here. Who plays? 2 people at least, so you can play with like 4 or something, are required if you want to play, 1 at each end of the table. You can also play with more if you like. Okay, so what type of equipment is required? There are 2 paddles, like this, 1 ball, 1 net, and 1 table. So here is a picture of a table, what a table might look like, and there's a line in the middle, so if you want to play with 4, there's 2 sides. So here's some interesting facts about ping pong. There are tournaments held for this game. This game is also called table tennis. That's what it was originally called. And in 1880, Victorian England invented ping pong. Ping pong is also played in the Olympics. And there's tournaments in the Olympics. Okay, so Newton's 3 laws of motion. Newton's first law. Objects in motions tend to keep moving, and objects at rest tend to stay still unless acted on by an unbalanced force. The greater the mass, the higher the inertia. Newton's second law. Force is equal to mass times acceleration, or F equals ma, is the formula. When the same force is applied to an object with a lower mass, its acceleration will be greater. If the same force is applied to an object with a greater mass, its acceleration will be less. And Newton's third law. For every action, there is an equal and opposite reaction. For example, if the action force is pushing on the desk, like if a book was pushing on the desk, then the reaction force is the desk pushing on the book. These 2 forces are equal, so nothing moves. If the force of the book was greater on the desk, then the book would sink into the desk or something. Here's a picture of Isaac Newton. Okay, so Newton's first law of motion in ping pong. Newton's first law of motion applies to ping pong in many ways. If something is at rest, then it will stay at rest until an unbalanced force acts upon it. If something is in motion, then it will stay in motion until an outside force acts upon that object. So 2 examples are, firstly, if a ping pong ball is rolling across the table, then it will stay in motion until an outside force acts upon it to cause it to not move, to cause it to stop moving. Secondly, if a ping pong ball is at rest, then it will remain stationary until an outside force causes it to move, like maybe you hit it across the table or something. And then the unbalanced forces that make the ping pong ball move varies depending on the situation. Sometimes a ping pong paddle will be the cause of the ping pong ball moving. Other times it might be your hand picking the ball up. If the ping pong ball is already moving, then you might hit it with a paddle to get it to the other side, or to stop it with your hand or foot to keep it from moving. Okay, so here's a picture of an object at rest. Here, the ping pong ball isn't moving. And here's a picture of the object in motion. See, the ball is in midair and the guy's about to hit it back to the other side. All right, Newton's second law of motion in ping pong. Newton's second law applies to ping pong because the ball accelerates more or less depending on how hard you hit the ping pong ball to the other side of the table. 2 examples are, firstly, if you hit a ping pong ball with a paddle and spike it down on the person across from you, it will accelerate a lot more than if you were to just lightly tap it to the other side. And secondly, if you hit a ping pong ball and a bowling ball against your paddle with an equal force, then the ping pong ball will go a lot further than the bowling ball because it has less mass. And here is a picture of the ball in motion, and it's they're actively playing. So Newton's third law of motion in ping pong. Newton's third law of motion is used in ping pong because whenever two things come in contact with each other, there is an equal and opposite reaction force. Two examples are firstly, the action force is a ping pong ball hitting a paddle, and the reaction force is the paddle pushing on the ping pong ball and sends the ping pong ball in the opposite direction. In this case, it would be the other side of the table because that's where your goal is to hit it. And secondly, the action force is a ping pong ball hitting the table, and the reaction force is the table pushing on the ping pong ball. And here is a picture of the paddle and the ping pong ball coming in contact with each other. And then here's the second example of the ping pong ball hitting the table. So it's going to hit the table right there. So if it hits the table here, then it's going to go over there and hit the table over there. So here is my references that I used for this video. Thank you for listening, and that was my presentation.